Welcome to my channel, everybody. This is the chapter about hyperbola. This is one of the part of the conic section. Hyperbola. This is one of the part of the conic section. And in my previous video, there is a discussion about the conic section like ellipse and parabola. Okay. And from the definition of conic section, there is some point on the curve like P, and S be the focus, and then PS by PM, where M is the perpendicular distance, PM is the perpendicular distance from any point to the directrix, and then PS by PM is equal to E, and where E is called the eccentricity, and for parabola there was a E is equal to 1, and for ellipse there is a value of E lies between 0 to 1, but for the hyperbola, the value of E is more than 1, okay? And now discussion about the hyperbola. See the drawing here. And this hyperbola, there was a two axes, there is a transverse axis and conjugate axis. And now difference between the axis of transverse axis and conjugate axis with the ellipse. There was a major axis and minor axis. It means the minor axis means less and major axis means more. But about the hyperbola, there was no needed to more length with the transverse axis and conjugate axis. Okay. So now see when we call hyperbola be a hyperbola, then what is the conjugate hyperbola? There are the two relation between the conjugate hyperbola and normal hyperbola. See here is a drawing. Okay, and this length is called , 2A, but here is called A and A dash and A here, okay, and this length and that is called A and A dash. And this called the transverse axis. But this is B and B dash is called, that is twice B, is called the conjugate axis. Okay, and here is the focus, that is S, and this is S dash, and this is the foci here. You can in plural form, focus is a singular and foci is called the plural form. Okay, now for the S coordinate, that's same as ellipse, AE, 0. Okay, and this nature of the theory of some point are related with the same looking same as a ellipse. Okay, so it is easy to learn the theory of hyperbola. Okay, and this is S here, that is AE, 0, and the directrix, and directrix is here. This is a directrix, and this also another directrix, same as ellipse and hyperbola. There are the two directrices, but for parabola there is a single directrix. And see, this is 8 minutes. For ellipse, that is called the intersection. This is called Z, and this is here Z dash, and P here is any point. Okay, and now equation of directrix here is x is equal to A by E. And this is here x is equal to minus A by A. Okay. Okay. And now we have to prove the equation of hyperbola. As you know, the equation is now x square by A square and y square by b square is equal to 1. But it is not possible see here, PS by PM is equal to E, is the universal truth for conic section. It is PS by PM equal to E here, okay, and E is more than 1. E is here more than 1. We have to prove this equation. And now PS, and that is equal to E into PM. And PS means this is the distance from focus with P. This is PS. So this is here, and P, the coordinate be here x, y. So now x minus AE whole square and plus y square. This is here E, and this is PM. And PM is the perpendicular distance from P to the M. Okay, this is here M. This is mega 90 degree. So now PM is perpendicular distance. Equation here is x minus A by E. So you know the distance of perpendicular is from P to the line is this. Okay, and the variable y is absent here, so we can assume as the variable be 0 dot y. We can like that 0 dot y here. Look like 0 dot y here. Okay. X minus plus 0 dot y and minus A by E. So that's why the coefficient of x square and y square be here 1 square plus 0 square. Okay, and we get here E into, that is x minus A by E, and multiply by E here x minus A. And squaring both sides, squaring both the sides, then and see what happened. And x square A square E square minus twice x AE plus y square, and this is here x square E square plus A square minus twice AE x. Okay, on the both the side, the two part like these and these are cancelled, and see, you know, the value of A here is always more than 1. So we take a common here, look like if we x are transferred to the right hand side, then we get here E square minus 1 into x square, and this is the logic for is E is more than 1. Okay, in case of it is, so you can transfer this part on the left hand side, but as we know the value of E is more than, so this part are transferred to the right hand side. As we know the value of E here is more, and same as here is that is here is and transferred to the right hand side, that is y square. This is minus y square. Okay, and now remaining all are transferred to the left hand side, that is constant, that is A square, and this is the A square. So A square taken common, E square minus 1, and divided by A square and E square on the both sides, then we get here E square minus 1 into x square, and divided by A square into E square minus 1, and same as y square by A square into E square minus 1, and this is equal to 1. So these two factor E square minus 1, E square minus 1 are cancelled. So equation is there x square by A square, and students see carefully, and B square by here A square into E square minus 1. So we can later assume as a B here. So that is, we can assume as a B, that is x square by A square minus y square by B square is equal to 1, since B square equal to A square into E square minus 1. Students, see carefully, in the case of the ellipse there was a relation between A and B with E. There was a B square equal to A square into 1 minus E square, since you know the value of E there was there is E is less than 1, and which is 0 to 1, but here is E is more than 1. So that's why we can write B square equal to A square into E square minus 1. Okay, so there is a both difference between the relation between this B, A and E. Okay, and some point other is here the transverse axis here is twice A and the conjugate here is twice B. And the foci is a comma 0 and minus a comma 0, okay. And so this is 1 point, and this is a 2 point, and this is a 3 point, and for length of lattice rectum is equal to 2b square by a, okay. And furthermore, we want to introduce some point like 6, the coordinate of foci. Foci are a comma 0, this is s, and s dash minus a comma 0 here, okay. Number 7, the equation of directrix, the equation of that is x is equal to plus minus a by b, and this is one is a by minus a by e, and this is plus a by e, okay. Okay, and these are all the points, and which I introduced here. And now see the another point. What is the conjugate hyperbola? If the transverse axes are a conjugate axis and conjugate axes are a transverse axis, then that type of hyperbola is called the conjugate hyperbola. See, and this is depend on what the nature of that. This is the equation of hyperbola for natural hyperbola. See, again I write here. This is the point x square by a square. See, y square by b square. Okay. This is your point. And for the conjugate hyperbola, and this is your equation. This is your drawing. And for conjugate hyperbola is this. So what is the equation of that? Then it would be x square by a square minus y square by b square is equal to minus 1. Compare with that. But in some book there was a written by that is y square by b square and minus x square by a square, and some book written y square by a square minus x square by a square b square equal to 1. But this nature is easily to be learned about that. X square by a square minus y square by b square equal to minus 1. Okay, and same say for that drawing is here minus 1. Only there is minus 1. So you can easily say that the focus, and this is the focus. So then the focus are 0, comma and BE, and for the conjugate hyperbola BE and S dash B and 0, comma minus BE. And the equation of directrix, and for the coordinate foci is this, and for the coordinate of directrix we can for this drawing here we can write here y is equal to plus minus that is here b by e. Okay, this is b by e. Okay, and this is here b by e as here b. That is b or b dash, and b dash, and that is length bit twice b is the transverse axis. Okay, not major axis, transverse axis. Okay, now the another point, the relation between b and e, b, a and e, that is b square, nothing b square, it is a square is equal to b square into, and this is e square minus 1. Okay, and the length of lattice, and that is the 4 number point here is, and this is 3. And this is here your discussion about 7 point, and this is 7, this is C as 6 point, and this is 4. About the 4 is length of lattice rectum, that is b 2a square by b here. Okay, okay, students, carefully. Okay, this point very important point. Okay, about this discussion I also want to prove that the condition is this. This is number 1 and this is number 2 for the 9 number point. Okay, and now see, now we have to introduce here, and now learn the point about carefully. Okay, students, see, and now there is this problem for doing the question number 9. Okay, see, Now this is here x square by a square, and this is here y square by b square equal to 1. We write here b square by a square, y square by b square is equal to 1 minus, that is not 1 minus, this is here x square minus 1. Okay, now see, take a LCM here, a square, this is x square minus a square, and now here y square by x minus a, and this is here x plus a, and now b square by a square. Okay, now this is look like we shifted as a is a okay, this is s. Now we draw a perpendicular. Okay, this is n. So from x comma y are here p. So this t length is called y. So we can write here in place of y, that is a pn square. Okay, and this is here x minus a. This is here x minus a. See what is the meaning of x minus a? See distance from this is called center. Okay, see this is center. The coordinate b has 0 0. So from that we can write here x minus a, and this is from this to this to this b here x. Okay, this together is x, and that is here minus a, and that is a n. So that is cn, and minus that is a, cn minus cs, ca, and that is cn, sorry, cn minus ca. Okay, and again x means this is here cn plus from this we can write here ca dash, that is b square by a square. So pn square. So look here, c n minus c a, that is a n. So you can write here this is a n, and it is also a dash n. Okay, look, a dash, I think n, and this is a and this is x, so a dash n, and that is equal to b square by a square. Okay, students, carefully. But now I want to introduce the second point is that, and that is number 2 here. See, for this two, question number 9 part 2. You know that is PS by PM is equal to E, and PS is equal to E into PM. In place of PM, and this is here PM, so this is parallel to Zn. Okay, we can write here E into Zn. This is a Zn. In place of Zn, we can write here from Cn minus Cz. Okay, Cn minus Cz, that is Nz. Okay, this is Nz. We want to write here Cn minus Zn means Cn minus Cz. This is here E into Cn minus Cz. You know the Cn length here is x, and Cz, this is the directrix, equation x equal to a by e. So length from center to that is a by e here. So multiply that ex minus a. Now we have to introduce another point. The P S dash is equal to E into PM dash. that is here okay PM dash, and that is okay, so we can write here A into PM dash. PM dash means there is Z dash n, okay, Z dash n, same as E into Z dash n, Z dash C plus Cn, the length of Z dash C means this is a division of directrix, so this length is from center to that, A by E, and Cn, this is center from to N, and that is denoted by xy, so this is x, so multiply by E, then AE plus EX. So now PS dash minus PS. PS dash means that is A plus EX, and this is minus EX minus A. So that is twice A. It is proved. Okay, students, see carefully. So this is the basic theory of the hyperbola. And now some problem we have to introduce here. See carefully. Okay. So this is question number I've done. Okay. Now for 3, we have to introduce here question number 3 here. So E1 and E2 with respectively the eccentricity of hyperbola and its conjugate. And for first hyperbola, if this, then the relation between A and B here, B square equal to A square into E1 square minus 1. And for conjugate hyperbola, then equation B here, this is minus and and then we can write here the relation is B, A square is equal to B square into E2 square minus 1. Okay, this is 1 and this is 2. For 1 and 2, multiply both the equation, then we got the relation. See, B square equals the ring 1 into 2. The equation 1 into 2. Okay, A square B square, and also on the right hand side here A square B square, and the 2 factor we have E square minus 1 and E2 square minus 1 here. And these 2 factors are cancelled. So we have 1 in the on the left hand side and multiply by these 2. So you get here E square and E2 square. And so minus E square, E1 square, minus E2 square, minus plus, so 1 will cancel. So here E1 square plus E2 square, okay, and that is on the right hand side E2 square, E1 square, okay. So divided by on the both the side by E1 square and E2 square, then we get here. So E1 square by E1 square and E2 square plus E2 square by E1 square and E2 square, okay. Then we get here 1 by E2 square plus 1 by E1 square is equal to 1. Okay, so I have done the question number 4, question number 3 also. So see the next question. Okay, see the next question is here. Now the 9x square and 25y square is equal to 225, and divided by 225, then we get here x square by 9 5 is there 5 9.3 okay. If we divide it by 2 to 5, then we get here 25, then y square by 9, and this is equal to 1. So a square is equal to 25, then a equal to 5, and then b equal to 3 also, okay. And now this question is given, but what is the part of question there is that find the length of the transverse axis. So number 1 point we can write here. And now find first the eccentricity, and then the other point we calculate easily here. So here is the relation b square equal to a square into e square minus 1. So see, this is the plus 1 and x is the first. And now put here is 5 means there is a 25, and this is here 9. So we can write e square minus 1, okay, e square minus 1. So now 25 by 9, and that will be plus 1 also, and this is e square. So here 25 plus 9 by 29, and this is e square. So therefore e means 25 and 9, and that means 4 and 34. 34 by 9. So this is e square. So e is equal to root over 34 by 3. Okay. So again check the calculation. Okay, I am doing some wrong. I am doing here some wrong. In place of b square value is 3 here. Sorry. It is wrong written. See carefully again. Okay. I am doing wrong. Okay. And this is at 9, okay, now, and 25 here is, okay, see, e square minus 1. So 9 by 25, and this is b, and this is e square minus 1. See, so e square is equal to 9 by 25, and this is also plus 1. And see 25, and 9 and 25, that is 34. So e is equal to root over 34 by 5. Okay, so see, this is more than 1. Value v has more than 1. Now also another point we introduce here, that is the length of transverse axis. So number 1 point, the length of axis, that is twice a. So you can write here that is 2 into a means 5, so 10 unit. And number 2 here, the length of conjugate axis, that is 2b. So 2 into b here is 3, so this is 6 unit. Okay. Number 3, the ordinate of center. See, this is the center is 0, 0. Okay. And number 4, the coordinate of 4c, that is a, 0. A means here 5, e means here root 34 by 5, 0. And also 5 are cancelled. So, and h dash is minus a, 0. A means 5, e means root 34 by 5, 0 here. So these 5 are cancelled. So this is root 34, 0 and minus root 34, 0. And now 5 is here equation of directives. The equation of is here x is equal to plus minus a by e. So you can write here plus minus a. Again a means 5 and e means that is root 34 by 5, that is 5 by root 34. That is 25 by root 34. Okay. So this is all the points for question number 1. And now see, we also introduce the point number 2, and this is a very interesting question. And in my previous video about the point number 2, this was on the chapter of ellipse and parabola, and same as here is the hyperbola. See. Okay, so students, again I see, I want to saying you, all of you, in some book there was a more points are introduced, but not needed to learn all that point. We should always a basic concept we learn this, and then you will easily follow the chapter. Okay, so now see the question number 2 here. So here is 3x square and 3y square, 18x. This is 12 plus 2 equal to 0 here. Now see again 3x square. Here taking a common 3. So all of you know the pattern of that. Okay, 3, 6 are 18. So there is a x here. Again common, take a common 3 here. That is 4y square. It's 4y. Okay, on the right there is a 2. Okay, so now 3 x square, this is 2 into x and this is 3, so we added a 3 square. So 3 square into 3, this is 27. Mainly we added a 27, see carefully. And 3 into y square minus 2 dot y dot 2 plus we added a 2 square. If we multiply by 3, then that is a 12. This is minus 12, so values on the right hand side is minus 12. And see again on the right hand side there is a 2. So we added, that is a 27 on the left hand side. So added 27 on the right hand side, then it is balanced. And again on the left hand side there is here is a 2 square. If you multiply by 3, so then we get here minus 12. So for balance we added a 12 on the right hand side. Okay, this is complete. So now 3 into x minus 3 whole square, and that is 3. We have a y minus 2 whole square, and that would be a 12 and 2, that is 14. If we subtract from 14, that is here 14, that we are 13. Okay, that we are 13 here. So divided by 13 here, that is x minus 3 whole square, and by 13 by 3, and also y minus 2 whole square by 13 by 2. And see students, another point I want to introduce here. If the equation be x square by a square and y square by b square equal to 1, if a equal to b, then we can write here, and this is okay, and this is here. So that type of hyperbola is called the rectangular hyperbola when a and b are same. When a and b are same. So you know the relation between a, b and e here is b square equal to a square into e square 1, e square minus 1. As b and a are same, so these two are cancelled. So now y1 equal to e square minus 1. So e square is equal to 2 and then e equal to root 2. Okay. So that's why. So for every rectangular hyperbola, the eccentricity is here root 2. Okay. And now for that here is b and a are same. So a square is equal to 13 by 2 and is equal to b square. So therefore a is equal to b is equal to root 13 by root 2 here. So see the calculation carefully if there is some mistake or manage it. Okay. So I think I'm right here, but see the calculation carefully. Now see this point need to be the point. Okay. The technique of the solution and point to the okay. Now see here is the equation. Okay. Now I have also some point we have to introduce. Okay. Now this is the rectangular hyperbola. Is a complete discussion here. And now the some point we want to show in that. Now point number 1 is the center for coordinate of center. You know the center is 0, 0 here. So this is the basic drawing. You know, first of all we always discuss with you. So that is we can say that the x is 0 and okay. First now we reduce the equation of the basic. Okay, let x is equal to x minus 3 and capital Y equal to y minus 2. So that's x square by 13 by 2, and this is here y square 13 by 2, and this is equal to 1. Okay, and see this is 0 and y is 0 here. And now see x means that is here x minus 3. That is here x minus 3 equal to 0 and y minus 2 is equal to 0. So x is equal to 3 and y equal to 2. Therefore the coordinate of center be here 3, 2. Okay, number 2, we have find the eccentricity, b square equal to a square into a square minus 1. So this is 13 by 2, this is also 13 by 2. So in place that e equal to root 2 here. So now this is the third point is 4c. For 4c, x is equal to plus minus ae, comma, and y equal to 0 here. So x means x minus that is 3, and plus minus a means here this is root 13 by root 2 into root 2, and that is equal to root 13, and y means y minus 3, y minus 2, so y equal to 2. So for 4c, therefore the coordinate of 4c is just be, this is 3 plus minus root 2 are cancelled, so that will be a root 13 here. So 3 plus root 13 comma, and this is 2. Okay, and the length of later sectum, that is here 4. The length of so 2b square by a, 2 into b square means 13 by, this is 2, and a means also root 13 by root 2, and simplify this length. Okay, that's all. Then equation of directrix, also next point here is equation of directrix. X is equal to plus minus a by e. X means is x minus 3. This is equal to plus minus a means root 13 by root 2, and here is e means root 2. So that is here 2. This is here 2. So 2x 6 plus minus root 13. This is the equation. So this is minus 6 and root 13 equal to 0. Okay. And now some another point look like a easy problem. As I have done the problem number 1, 2, 3 and 9, and see here question number 4 is that you have a given the equation x is equal to a into 1 plus t square by 1 minus t square, and also y is equal to twice at by 1 minus t square there. Okay, now x by a is equal to 1 plus t square and 1 minus t square, and also have y by a and 2t by 1 minus t square. If we are doing and like x by a whole square and minus y by a whole square, then it will be a 1, I think. See the calculation here. Okay, 1 minus t square whole square, and also 4t square by here 1 minus t square whole square. And take LCM here 1 minus t square whole square. And that is that if we 1 plus t square whole square minus 4t square. So you can write here. So 1 minus t square whole square by 1 minus t square whole square equal to 1. So you can write x square minus y square equal to a square. So it's a rectangular hyperbola. And actually find the eccentricity, saying that find the eccentricity. You know the relation between the a square into e square minus 1 also. So since a equal to b here, so you can write a square equal to a square into e square minus 1. Okay, so a square cancel, so e square equal to 2, so e equal to root 2. So this is the rectangular hyperbola and eccentricity is here. Root 2, see, very easy question. Okay, now the another point is question number 5. The hyperbola is x square by a square and y square by b square. And see, this hyperbola passing through the point of intersection of these two lines, and 7x plus 13y and 87 equal to 0, and another line is 5x and 8y plus 7 equal to 0. And solving this two equation we get the point, and therefore the point of intersection, therefore the point of intersection that is I think 4, 5. Okay, no, this is 5, 4. This is 5, 4 actually. Okay, so you know the solution. Okay, now so that's why I only directly use the point here 5, 4. And now this curve and this curve passing through the point 5, 4. Okay, the curve, the hyperbola, passing through the point that is 5, 4. Okay, therefore that is 25 by a square and that is 16 by b square equal to 1. This is 1 point. And now another point given that the lattice term. Okay, you know the lattice term b 2b square by a, 2b square by a, that is here 32 root 2 by 5, and implies that, so b square here is 16, 2 are cancelled, so 16 root 2 by 5 into a here. Okay, put b square on that. Okay, now 25 by a square, this is 16 by b square, that is 16 root 2 by 5 into a, this is 1, so 16 are cancelled. So now 25 by a square. So my this is 5 are transferred to the numerator part, and that is 2 into a equal to 1. And take a LCM, that would be that is we can write here a square, that is 25 root 2. Okay. Now 5 into a. Okay. And this is root 2 into a square. A square into root 2 is the LCM. So a square into root 2, that's why 25 root 2. A square into root 2, that is a is LCM, so 5 into a, and on the right hand side root 2 into a square. So now we can write here root 2 into a square and plus 5a and minus 25 into root 2 equal to 0. If these two factors are multiplied, then we get here 50. So 50 can be written as a 10 minus 5, okay, 10 minus 5. So that's why root 2 into a square, that is 10a minus 5a, and that would be minus 25 into root 2 equal to 0. And then take a common, root 2 into a. So a plus 5 root 2, and take a common 5, a plus 5 root 2 is 0. So now we get root 2, and this is 5, and other factor not be possible, as we get the value of a is negative, so it can't be accepted. So a is equal to 5 by root 2 here. Okay, this is the value of a, and so we can easily find the value of b here. So now you know the value of b and a are also positive, so we can't take a negative sign. So now 16 and root 2 by 5, and a here is 5 by root 2. Okay, here. So this root 2 and root 2 are cancelled, 5 are cancelled, this is 16. So you get here b is 4. So b is 4 and a is this. Okay, b is 4 and a is this. Okay, right, very important question. Okay, now see the again the other question here. I want to 2 or 4 question I want to introduce also here, and see there and find the coordinate of 4c of the rectangular hyperbola. Also this is easily, as the more the problem already we have discussed there. So you know this is a and b are same, this is called the rectangular hyperbola, so e is here root 2, and A is 3 and B is also 3. So we can easily find the 4C. So C again, okay now. And 4C, you have to find the coefficient of 4C. So x square minus y square is equal to 9 here. So x square by 9 and y square by 9, and this is L1. So A equal to B equal to 3 here. So E is equal to root 2. So 4C means plus minus A comma 0 here. And this is the A plus minus A. A means here 3 and E means root 2 comma 0 here. So this is plus minus 3 root 2 comma 0. Okay? This is according to 4C. Okay, now see again. I think the more of two problems are left here. So see, E is 13 by 3 and and sum of the square of the length B is 5, and find the eccentricity. Find the equation of the ellipse. Let the equation be a hyperbola. Sorry, not a ellipse. It's a hyperbola chapter. Okay, now some will be some point or okay now. See, this is a hyperbola. Okay, here is E is equal to root 13 by 3. And sum of the square of the length of the axis. We know the axis we are twice a square and twice b square. It is given, and that is 25. Okay, and see, this is 4a square and 4b square, and that is 25. And see, here is b square, and that is b square equal to a square into e square minus 1. So b square means there b square, okay, a square, and e square means 13 by 9 minus 1. So b square equal to a square into 13 by 9, 13 by 9, 13 by 9, 13 minus 9, and that is 4. Okay, that is 4 a square, and this is 4 b square. B square means a square into 4 by 9 equal to 52. So see, carefully, easily you can find the value of a here, and also the value of a put in this position. Okay, see, 16 is 36 a square and 16 a square, and 52 into 9 here. So we can easily find the value of a, and also put the value of a here. We can easily find the value of b. Okay, this is your solution. And now see, the last question is this: the condition, that is find the locus here, is x by a and y by and b is equal to m, and the another case is m into x by a and this is y by b here. Okay, and this is equal to 1, and put m here, m, that is x by a and y by b. This is m, and this is here x by a plus y by b, and this is 1. So we can write here x square by a square, and this is our y square by b square is equal to 1. So this is the equation of hyperbola. Okay, bye everybody. See carefully, this is the chapter of hyperbola. Okay, I think all of you are better understood of my lecture, or see carefully in my video. Okay, bye everybody.